Marquise, what up, my boy?
It's live. Do this all the time. Marquise can wait.
Yeah, I'll call you back, bro.
Howdy, welcome back to Swedish News Now. My name is Clark Ansley.
I'm James Nieberding.
I'm Trip Tyree.
And today, on this beautiful, bright, and sunny day, we bring you a compelling story about how solar photovoltaic systems provide power to the grid.
This one's dedicated to Dr. Davis, ECEN 340 at Texas A&M University.
Take it away, boys. And now, we're going to send it over to our expert award-winning analysis, Trip Tyree, as he explains the main driver behind PV systems. Take it away, Trip.
That's the sun. Over there.
What my colleague was trying to say, solar cells are a combination of differentially charged plates of silicon, one with excess electrons, N-type semiconductors, and one with a lack of electrons, P-type semiconductors. Photons from the sun here, as you can see,
hit the electrons in these silicon plates. This causes electrons to jump to an excited state and flow through the semiconductor material across the p-n junction located here. The electrons jump from N-type to P-type semiconductor material. We then can connect a circuit to the semiconductor material to create a current that flows to the next stage of solar power generation. Individual cells typically generate around 1 to 2 watts and are thinner than a human hair. Their power output is also inversely proportional to temperature. The hotter it is outside, the less efficient the solar cells are and less power they generate. There are multiple types of solar cells also: silicon solar cells, thin film solar cells, and many next generation solar cells.
well, I'm going to send it to Dumb and Dumber as they explain the next step in the process of PV systems.
Hey bro, do you know how these work?
Not really, bro.
Can you explain to me like I'm 5?
Okay, so I think what happens is the sun right here goes to the shiny plate thing. Like they're usually on roofs. I think that's how I don't know. My dad has a few. Then I think they drew this wrong. Isn't this a converter?
No, I'm pretty sure it's an inverter.
I'm pretty sure it's a converter, bro.
No, that's definitely an inverter.
Are you stupid?
No.
Sorry. I don't know what they were complaining about, but solar PV systems uses inverters. Inverters take the DC output from the solar cells and converts it to an AC output, which then can be used by the grid. This is then used to power everyday systems like our laptops and phones, which I'm reading off right now.
There are multiple kinds of inverters, with a few basic ones pictured here, which we learned in class. Solar PV systems use either one, and it really depends on the needs of the system and the load that is being inverted, since most inverters are roughly 96 to 97% efficient. Inverters use an inverter loading ratio, or ILR for short, to define what percentage of DC capacity is converted to an AC power rating. To maximize the AC output, we want a high ILR, as shown here, to produce more AC power with the same solar cells.
Reporting live deep in the field, Clark Ainsley with a real Liddy solar PV system. Can you believe it?
Solar panel, inverter, but no sun. Sun.
Sorry. As you can see here in this diagram,
Here we can see all the stages of a solar PV system. To start off, we have the sun and the photovoltaic effect that captures the energy from the sun. The DC current created by these solar cells is then sent to an inverter, which then creates an AC current that is needed to power a house or sent back to the grid. If there's an excess power, this can then be sent back to the grid, and the current has to pass through a network meter. This is typically used to measure how much power a resident or consumer uses. However, since the power from the solar cells is in excess, it can be sent back to the grid for others to use. The meter can tell power companies how much power is being added and allows, in many cases, residences to be paid for their power generation. And with that, you now understand the different parts of a solar PV system. They come together to create clean power that is quite passive in its creation, unlike other forms of mechanical power systems.
Well, that is the end of our broadcast. Hope you learned something. But anyways, let's send it off.
It's anthem time, boys.
Salute the flag. That's not the anthem!